God, where the hell is it here? Config list. Properties. No, I didn't have to do this shit before. I don't know what the. I don't know why it's doing that. I really don't. This thing is all screwed up. Jesus. Alright, so the deal. I have to go to my. Still logged in over here. Alright, now if I go to my Mars, I will let you all know that now I'm getting the pyrite, this pyrite section here, this is actually working now. However, the reason it's working is because I commented out the output of magnesium sulfate. And I don't know why. That's not working. See, I've got an input here to split magnesium sulfate. Okay. And then I have this. Input magnesium sulfate and 7 water gives me 1 Epsom salt. And all this other stuff is working. But I only use the magnesium sulfate there. And I use it here to split it, and I saw that that worked. But to collect it, it's not working. I must be missing something really stupid. It must be like right in front of me and I can't see it. And I just don't know what the hell it is. It's like a typo or something. Because Split Mars Rock 3 is working. I can get my pyrite. Oh, I see it now. I see it. It's fucking spelt wrong. I knew it was a freaking typo. I just freaking knew it, and I couldn't figure what the hell, you know? It was a typo. I freaking knew it. I knew it was a typo. It had to be. Alright, good. Now, magnesium sulfate, that is actually... Oh, wait. Magnesium oxide is 5%. Am I collecting... Magnesium oxide is more like 2.5%, isn't it? Oh, that's manganese. Oh, magnesium oxide's over here. Oh. Wait a minute now. How can I collect magnesium sulfate off of the surface of Mars? So we're reading about they're saying magnesium sulfates contain water. Well, that's your Epsom salt with different hydrate levels. Well, they're saying it does exist on Mars. Uh, but it's not on that chart, though. Kieserite is a form of magnesium sulfate. Hmm. Well, they're even saying that it's on Europa. Okay, well, that's interesting. Um, so maybe it's available at a higher level, maybe 1%. If that's the case, I could drop my numbers down. Why don't we do that? And then I gotta figure out these other numbers. Alright, I'll go with it. Now, what we have to do on the next test is to test. Probably have to split Mars rock and see if it's the same timing. I got the timings right on this, but on the other one, alright, so like if there's so if I divide, well, I was doing split Mars soil 1 20 at 0.2. So if I do, wait, where's the 20? Oh, this has to change to a different number. 0.4. So I could do that again and see if it takes an hour. Now the other problem is this. Oh, that's because I've got 1 unit. Let's put this down here. Well, I've got 1 unit here and the numbers is set at 4, which is what I didn't understand. I don't know. It just doesn't make any sense. That's like less than a second. If I multiply that input by 10, it's supposed to be 0.4. I wonder if I got these numbers backwards. See, that's another thing. You know? If the number is higher, it goes quicker. That much I do know. And I gotta change this heading here. Mod changes in it. Let's see, mod. Oh, let's call it part 3. Whatever. So, if I'm doing 0.4 for 10, don't I do 0.04 for 1? That's what I don't know. I got these numbers all wrong. I think these numbers are right. It's supposed to be a 4. That 4 and 1 doesn't make any sense at all. It just does not make any sense. I just gotta do this with trial and error. I don't know. If this is 10 units, if this is 20, if this is 10 units, it's supposed to be 0.4. I swear to God, I just don't know. It seems like it should be. How could it be a 4? Because when I ran this, it was like less than a minute at 0.5. All these timing conventions are supposed to be the same. And I don't know what the fuck is going on. I guess they're different somehow. Jesus. What a mess. I'm thinking of just doing 0.01 and trying it. I don't know what else if I can do here, really. And what's pissing me off is that I gotta keep making this every time. I can't save a game and go back in and change something. I have to redo it every single time. You know, I got an idea. I've got an idea. What if I use... What if I put in... maybe I can do this without... You know what I mean? Jelly bean. Oh, God. So what I'm going to do is... I'm just going to call this split iron. I'm going to input iron. And I'm going to output something. I'll output carbon and oxygen. And we use 1 unit. I tell you what, let's do... This one's going to be split iron 2, and I'll figure out the timing on that one later. So what I want to do is I want to I've got a 2 down there, and a 10 and a 4. I want to make this a 2. Not that that stuff makes any difference. I could leave those numbers the same. So now I can just grab, I can put a I can get a canister of iron down there from that thing. And I should be able to use the same one each time. Now, as far as naming conventions go, I don't know what to do about that yet. I would actually like to start playing the game. And I'm actually getting close. All I gotta do is figure out this timing on my processes and then create the mission and be able to survive the damn thing, you know? So I have to create another thing here for testing. Shit. Pardon my French. Now I need I should probably put the pop tent in here too. Maybe I can test that. I gotta test that oxygen use. If you want to remember where your supplies are, you have to go to the mobile thing here. And it's supply drop starting equipment. That's tipped pretty good, ain't it? This time I'm going to start this at 14. And it still has to be 24. Now, what am I missing? I need cans. So as far as I know, I can go into a new scenario without having to change anything and make changes. I wouldn't do it on a new game. So you got the small and the large, you got 3 of those, 3 of those. I need a soil extractor. Well, actually I don't, but I'll put it in there. To get the oxygen. I think that's it. So the big question is, can I get access to my stuff? And it would be on the top, wouldn't it? Well, that one is falling off. Kept hitting something. Oh God. Actually, I meant to grab that and put that in the soil machine here. That's green. Must have 2 of them. Oh shit, you know what? I forgot my notepad thing was just sitting there. that thing fell over. God, I'm not gonna be able to get up there, am I? Oh, shit, wait. Aye, crap. Wait, let's try it different here. I don't think I can. I might be able to. Come on, get up there. Alright, there we go. Now all I gotta do is find... Am I in the right one? I may not be in the right one. I thought the other one was empties. Drop it. Drop it. Oh my god, drop it. Well, I must be in the wrong one then. Oh, I guess I was. Oops. Alright, so I need that. Alright, so in our experiment, I've got iron set up for 2 different timing settings. I'll wait till this gets up to 40, and it is. And the first thing we're going to do is try to get our silicon dioxide done. Trying to keep this over. Yeah, I gotta move it. SiO2. Yeah. So this will take 2 game hours. It's 12 o'clock. Oh wait. Yeah, this one takes 2 game hours. So what I can do is I'll grab this one here. And we should be able to play with our timing here. So this is iron, and what I'm going to do is just split this into some random components. Which I already changed in my settings. And we're going to see how long. So I've got 1 hour done already, so we should have about 20 units of this stuff already spent. It should be going down pretty quick here. It's about an hour. I know that works. Alright, so now, let's see what we got in here. And we're looking for iron 1. We got iron 1 and iron 2, so we're going to do this one. And we'll see how long it takes. And it's 13:15 right now. And I want to find out when the first time it drops a unit. Yeah, the timing is slightly messed up. I love this game. What I set this to. I think I set it to, I didn't even write it down, did I? I think I set it to some number, 0.01 or something. I just need to have a number to start with, so it's already gone 45 seconds. This one should be done. Now, I don't care about that. And what I'm going to do here is just empty these resources. Uh-oh. Let's put that on the input. Run back over here and see if this thing did anything. And it did, so probably like an hour. That went 1 hour for 1 unit probably. Anyhow, so I gotta change that. Oh, now I want to try the other one, the other number. Alright, so now we've got, everything is all set to go here. Oh, wait a minute, I didn't change, well, this one actually is going to happen like within a few seconds because the number. Right now I'm just testing oxygen for the tent. this should happen right away. I don't think I didn't change anything with this. Reliability, right? Alright, now I gotta have... I can still use that iron, can't I? So now I go to iron 2, which is actually double the time, I think. So it's almost 1,500 hours here. So that took 1 hour. Now this one has, let's see, that's a 0.1 and this one is 0.2. So that's double. Or it should go in half the time, so that means I should get 1 unit in 30 minutes. Use 1 unit of product in 30 minutes, hopefully. That should turn over pretty quick here. It's been about 40 minutes. What's this almost going to go an hour or two? This is weird. I think it just changed. So that's like an hour. Huh. That's just weird. I don't know. This one should be all done. Oh, I see what I'm doing. Yeah. Alright, I've got to go back out of this and figure this timing out is not right. So now we'll just open up our notepad here somewhere. it's set to 0.01. So, oh, they were both set at 0.01. That figures. That's 1 hour. Alright, so if I double that, if I change this to 0.02, that's 1 unit in a half an hour. If I double it again, that's 1 unit in 15 minutes. If I double it again, that's 1 unit in 7.5 minutes. If I double it again, that's 1 unit in 3.5 minutes. If I double it again, that's 1 unit in 1.5 minutes. And if there's 120 units, so if I double it again, and then let's see, 0.64, that's like 0.4 or 0.5. That's what I had before. That's what I have on all of these, is 0.5. Well, that should give me about 1 unit per minute. And I don't even need this in here, or actually I do. I don't need this one in here. I'm going to leave that one in there. Interesting. Let's go try this again. So each time I have to pack the mod, 0.5 is 2.5, so it's a little over 2 game hours for 1 can, which should be about right. I should be able to go to the scenario. So maybe I did have my numbers right and I just didn't follow through with checking it or something. Now I gotta wait for that thing to fall over. So we're going to go in there and grab that iron in that can whenever that gets ready to fall over. Or is it even falling over? It's not moving. Oh, it's actually the bottom one that I need anyway. I only need one can. Alrighty, now let's see what we got here. Iron 1. And what I'm looking for is to see if it will take over 2 hours, 2 game hours, to process that whole can. It's 10 o'clock. I think it's going faster than what I want it to go. Because I've got... Oh wait, no. Oh, those are just double the units, aren't they? So maybe what I'm looking for is for that number to drop down to 60 in 1 hour. Well, it might actually be close. I gotta go over here and see something. I can't see anything. Yeah, it's the amount is going up by 2 units. I thought that I had that one. Carbon's going up by 1 unit, so. This is just a random output. It doesn't mean anything. Alright, so it's 11 o'clock right now. And I still haven't gotten to the halfway point. But it's getting close. So there's the halfway point. So it'll take 2 hours, 2 hours and 20 minutes to do that whole can. I wonder if that's a good number. I should say, as much time I've spent on trying to get this stuff to work in this game, I should say, yeah, it's a good number. Let's just play the game. Yeah. 2 hours, huh? 2 hours. It takes I don't know. It takes, have I got oxygen? Is this oxygen? Yeah, it is, actually. I can test that tent out, too. I want to see something else. Alright, what I'm going to do is go over here. Is this thing? Let me grab a can here. I want to check out this soils machine here. Oh crap. I need a clock. So, well, it's 12 o'clock. That should be close enough. I want to grab this guy here. What we're gonna do is make sure that we've got... I don't want that machine to stop running. So we have to hook up 2 solar panels to get a slightly better efficient soil collecting machine here. And now what I'm doing is I'm timing the amount of soil that I'm getting off this machine. And we started around 12 o'clock. So while that's doing its thing, we're going to go over and test this tent out. Which I just happen to have some free oxygen kicking around. Ah, yes. Now what I'm going to do here is I've got 130 units of oxygen in that tank. I'm going to go in here. I hit control to crouch down. Was that like quiet? Oh wow, that's pretty cool. It just shuts down the sound in there. We'll drop this tent here, this hatch. We're going to pressurize this once. Now it says that the air is safe to breathe. I can take my helmet off and do whatever. And I won't die. La-di-da-di-da. I got the suit back on. Now, I don't believe I can open this. Okay. Oh, let's just blow myself up. Now I'm going to cycle this here. Open that. And find out what my oxygen usage was. See, it's only 1 unit. It only uses 1 unit in that tent to cycle it. It's like it doesn't hardly use any units at all. So I got 30 units of Martian soil so far, and it is That's an hour and a half. So that would be 3 hours for 60 units. So basically, what I'm looking at is, right, one day, wait, 30, hour and a half, 60 for 3 hours, and 120 for 6 hours. So one day, I get a full can of soil on a good day. I'll let that go up to 60. It's almost there. Maybe what I can do is power up this atmospheric processor and check that out. Because I do have a good use for that now. So there's about 60 units, and it's using about a kilowatt of power, so if you look over here, we've got 1430 hours. That's actually 2.5 game hours, isn't it? For 60 units. Wow. That's pretty good. 2.5 hours for 60 units of soil. So 5 hours. Yeah, 5-6 hours. It's about a whole day. Alright, now let's go over and hook this up here. Oh, come on, get up off of there. Alright, now we're gonna just check out this thing here and see what kind of productivity we get with that. It's 1500 hours. So we're gonna figure out how much. I should put another. What kind of power is this drawing? Oh, it's only drawing 600 watts. Alright, so let's see. ATM collector. uses one panel. So I'll let that thing collect for a while. So there's about 30 units. And it's like 1540. We'll have to let this thing collect half the can, I guess, to get a good average number. Well, what else can I do that's totally useless here? Actually, let's look at, let me get this guy out here. I want to look at my, I want to look at the stuff that's on here. Everything that's on the small refinery can be done with the large refinery, I think. It's just that it uses more energy. Well, it's not really doing anything right now. So we've got the Marscrete, we got that, we got the naming conventions I gotta work on. That was a new one I added for magnesium sulfate, aluminum oxide, which is already there. Well, actually that came from the other mod, and I just put it in my mod, actually, to get it to work. And maybe it was just a spelling mistake, I don't know. Here we collect nickel, which is a catalyst, and phosphorus pentoxide, and potassium oxide, and calcium oxide in their correct proportions to what's on the planet. Here I'm collecting chlorine, potassium oxide, phosphorus pentoxide again. I guess. This is the original Atmosphere 2. And then this is one I added. I'm going to use that atmosphere to collect methane off of methane pockets. That's not supposed to be there. That was fixed. There's my splitting of calcium oxide, magnesium, sodium oxide. Potassium is used for cleaning. Alright, so I got 81 in there right now, and the time is 1700 hours. I think I started at, it's like 2 hours, and I got 80 units. So I'm just gonna put a day. It'll give me more. So soil, 1 can per day. Atmosphere, 1 can plus. So that's 120 units. It's actually 130, but and the only problem with the soil is the iron. It's you don't get as much iron. That's the way it goes. We got your split hydrazine. We got a new form of plastic, which is called air carbon plastic. And I gotta work on the naming conventions, I think. Let's see, sulfur dioxide. That's to synthesize methane. Some of the chemicals I didn't synthesize because I didn't think you need to. Epsom salt used for your nutrients. That's water 1 and water 2 is the liquid waste. The first set of nutrients, synthesized nutrients, I should put nutrient in there. We're taking solids and creating a nutrient using chemicals. Then trace nutrient 1 adds iron and phosphorus. Oh wait just a second. If you go back here, as you can see, there's an input of chlorine for the liquid recycling. So now we actually have drinkable water, not just stinky water. And the chlorine is extracted from the ground, from the soils, I believe, somewhere. I believe it's right there. It does come in very small amounts, which is not really a big deal because we don't use a lot of chlorine in our waste processing. So that should be okay. And then over here, we've already got purified water, so he's just doing his thing here. The second water gives me a little bit more nitrogen on the output. So then we got our nutrient. Then we take that nutrient and we add iron and phosphorus to create trace nutrient 1. And then we take trace nutrient 1 and add Epsom salt, and that creates trace nutrient 2. And then we take trace nutrient 2 and add that to 10 units of nutrient, which is out of the waste product. The trace nutrients are just elements in water. And then the second one is another, the elements, because you can only add so much at the beginning. So now it's got all of that. And then we take the trace nutrient 2, add that to the nutrients, and we get our fertilizer. And then we take one fertilizer and we create a methane ammonia bed, and then we take another fertilizer and create a water bed. It gives off less methane and CO2. The ammonia amount is the same. Maybe I should drop the ammonia amount. Well, I don't know. It's giving that off. There should be lost materials in that. I don't know. I'm almost thinking it's giving off too much water. It's creating 20 units of water is what it's doing. It's like a filtration system to create water from these chemicals. And I didn't actually... I should do a chemical analysis and make sure that the amounts are somewhat correct. In other words, there's actually more methane and ammonia and carbon dioxide that's in the system, but it's used up. So a certain percentage is used up to create the water, which is H2O. The oxygen comes from the carbon dioxide, and the hydrogen comes from the methane, mostly. 20 units each. And that should be H2O. That's 20 units of water. Carbon dioxide. That's 20 units of CO2. And then there's the plastic and the fabric and the glue and all that stuff. Everything's there. Everything is there that I can tell. Where is... Here's where we get the pyrite from the ground. And we get hydrogen sulfide, sulfur dioxide, iron sulfide, and water and sulfur. And I think what I'm going to do here is I'm going to add sodium hydroxide. Like, these are drills, like these rock drills. Wait. Because the drill itself, I have no way to add the sodium hydroxide to the drill, which is a lubricant. So I'm going to put that in as an input here. And we collect the sodium hydroxide from somewhere. It's N2. I mean, it's sodium oxide is what it is. And I'm not seeing it. Where is it? Let's see. I don't see the sodium hydroxide. There it is, sodium oxide, number 3. So we're getting 4 units of that for every 20 Mars soil. So 20, let's see, 20, 40, 60, 80, 100, 120. That's 6 times 4. That's 24 units of sodium hydroxide. I mean, oh, it's actually sodium hydroxide that we've got. We have to make that, don't we? We have to make sodium hydroxide for these drills. So we collect Na2O, and then we have to convert that to NaOH. So that means we have to split the sodium oxide. So then we've got, then we have to combine that with a hydroxide. And so, alright, let me go back here. Let's see what time it is here. It's 10:30 already. So we add this. Now that one drill is collecting that. How can you even use the drill without without the stuff, you know? There's like a paradox going on. Sodium oxide is what's on the planet. So if we go back over here, click this. and sodium, it's at 20% sodium Na2O. So now what I gotta do is I gotta go to my list here. Making a hydroxide ion, an oxide molecule is incredibly strong base. Aye. Turning baking soda into sodium hydroxide. Nine steps with pictures. Salt is... what the hell is salt? Salt is NaCl. So you've got NaCl, that's salt. And you put that into water, and then you set up some electrodes. And you've got NaOH at the bottom. It's just electrolysis. So you've got salt plus H2O with electrolysis, and then you get 15% by weight of NaOH. So if I do Na equals 10, Na equals 100, Cl equals 100, and then I add H2O, then I'm going to get Na at 15. So if I do 10, 10, I get 2 sodium hydroxide out of that. That's chlorine. What happens to the waste chlorine? Must be given off as a gas. But I don't have that. Let's see. How to separate sodium carbonate. I got Na2O plus water equals, oh, I can convert it directly. I don't have to use chlorine. So Na2O plus H2O equals 2 NaOH. There's glass. That's used in the game. Wow, it even shows the percentages for making glass here. I don't even know if that was in the, what did they use for, did they use plastic? They used plastic instead of glass. I'm gonna bookmark this page here. And then I'll go to my notes and so Na2O plus H2O is 2 NaOH. So now we'll go to our chemistry. We're going to synthesize sodium hydroxide. Okay, that's another resource, isn't it? And it's not even listed here. Sodium oxide. So what I'm going to do, and this is hydroxide, so HYDRO and that just fits in there. Copy. Paste. And I'll use a slightly brighter color. So I got sodium hydroxide and sodium oxide, so let's save that. And then we go to our I'm going to synthesize sodium hydroxide. I'll put it in here. So let's see. Copy. Paste. Oh, actually this is sodium oxide and water. And there's one of each. And output we get 2 units of that. And that's our sodium hydroxide. Now we are going to go back into our wait, this is not it. We have to go back into our drills. We've got to add sodium so let's see. Let's use this one here. Copy. So for each one of these, we need actually, why don't I SODIU sodium I suppose I could just use 1 unit of, oh, that's actually going to be a lot, isn't it? In the drilling. I may have to up these numbers. Oh god, that means I have to change the timing all over again. Fuck. See, every time I change the input, I've got to change the units for the timing. That means I got to change all the numbers. Well, it has to be done because the drill has to have that. There's just no way around it. Oh, we don't need water. We need sodium hydroxide. I'm not sure if he must have had water in there. But that can be changed now. I just don't know about the usages yet. I just gotta add all this in here. Oh wait, the atmosphere doesn't use that, does it? The atmosphere does not use it. That's not a drill. Of course it is a lubricant. I mean, you know, maybe I should put it in there anyway. Fuck it. It is a lubricant, right? So we do have a slight paradox though. In order to get the sodium hydroxide, we've got to get sodium oxide. Where the hell is that? The sodium oxide's down here. So the question is, how are we going to get what we could have is we could have salt. We can add salt. We're going to have to add salt. This is cute, man. So we're going to have to use that formula. We got to have the salt. Need to decomp salt to NaOH for that first drill. Now the question is how much. Alright, so 20, 40, 60, 80, 120, so 6 times 4, that's 24 sodium oxide. So we got 24 plus 24 water, and that should give us 48 on that first run. Alright, that's 48 units on wait a minute. Na2O to H2O. Wait a minute, I'm doing something wrong here. I had to convert salt over. Wait a minute. Wait just a minute. Something's not right. We don't have salt in a container. Maybe there's going to be Maybe there has to be a special drill. Maybe the drill that collects the sodium oxide actually uses sodium hydro. It's already built in. You know what I mean? So maybe for that drill we don't need to use it. But there'll have to be something else in here. Alright, so if I take sodium oxide and mix it with water, I can get the sodium hydroxide. So what I could do, wait, what if I change this to water, which is what he had in there before. Now, for 24 units of, oh, this would this have to be a 4? Yep. But then that means if we use it, we don't get any of that material back. Sodium oxide. What if I use half the amount of water? No, I guess it doesn't matter. I guess we're just going to assume that we get what we need out of that, you know? That's the only thing I can think of. But the water should be in there, I guess, because that helps. But I didn't need 10 units. I only need 4. Or actually, I could put less in there. It doesn't matter, I guess. Alright, that works. Now the question is, if I've got 48 units of sodium oxide goes in, and 2 sodium oxide wanted to that comes out. So if I've got I got 48 units, and my first drilling operation is going to be to collect the S silicon dioxide. So if I'm using 5 units, 5 into 130 is 3, no, 2 times 5 is 10. 16 units. 16 units of sodium hydroxide in the first drilling operation. 16 units there. Let's make that a 2. This has to be a 4. In other words, each time it hits 20, 4 gets used. Okay, so 20, 40, 60, 80, 100, 126 times 4 is 24 units. And this one is 5, 10, 16 units. Doesn't make any sense. 6 times 4 is 24. 5 into 13 is 2 times 5 is 10. Oh, it's 26. 26 units. Where are we getting the sodium hydroxide from? Oh, we've got a problem. We have to collect the sodium hydroxide from with the small unit. So what that means, we've got to change something. Oh, shit. I may have to change all these numbers. Let's see. What the hell am I doing? Oh, I could call that a 1. Copy. Edit. Paste. Alright. That's 1. And this one is 0. Now what I've got to do is on this is a 5. This is a 4. That's a 3. This is a 2. And that's a 1. So on 1, we've got Mars soil, water, the output's going to be sodium oxide. Now, what is that percentage? I hope the hell I didn't fucking delete it. It's 24. So what I could do, actually, let's just grab this whole pile here, copy, paste. Now we're not going to collect calcium oxide. We're going to collect some stuff that's not as prevalent. So we won't collect the nickel. We could collect iron oxide, I suppose, because that's always used. But I'm only limited to 3 outputs. So And it's gotta be those percentages. The sodium oxide is a 4. 10 is a 2. It's 20%. 20% of sodium. Yeah. So I could collect the iron, or can I? No, maybe I can't collect the iron on that first run. So we're gonna take the iron out of this. It doesn't do any good to collect the water, because we're not going to be freaking using it for God knows how well I could collect. Well, yeah. Let's see. Potassium. Oh, there's 2 potassium oxides here. I thought something was funny. There's 3 outputs right there. What about the human waste? What is the human waste? I mean, what's the solid waste give me? I can't use... Actually, I need potassium. I need potassium. Wait a minute. Wait just a minute. Chlorine. Chlorine. We're supposed to collect the chlorine too, aren't we? How the hell do we collect the chlorine? I don't have a way to collect chlorine. The chlorine collection's not in there. Chlorine, if we bring this up on the chart here, it's at 5%. So chlorine is used to recycle water and water, but actually to make the nutrient beds, we don't have to, that water's not, we're not going to be drinking that water yet. So we can use, if we go through the nutrients, Epsom salts, manganese sulfate, and we've got iron phosphorus in water. So we're looking at, and then we've got we can make it says I need nutrient 1. That's the output. So I need phosphorus. Where's the potassium? There's the potassium right here. So the potassium, goes into the nutrient first, and then the phosphorant goes into the trace nutrient 1. So I need the potassium and the phosphorus, the other chemicals I get anyway, and that gets me to my fertilizer, which will allow me to eventually grow the methane, and then I can recycle that back to make the water. The methane is what's used to make water, methane and CO2. So what that tells me is that I need to have, I got chlorine here. I'm collecting it there. I'm also collecting potassium in that one. Now what about the phosphpentooxide? Where the hell does that come in? So I have to keep going through this. Oh, that's to get the phosphorus. Fuck. Well, what was I collecting up here? Oh, okay, it is that. The phosphorus pentoxide. But I'm also collecting it down there along with calcium oxide. Oh, you know what I could do? Calcium. I think I want to take out the sodium oxide. I could leave in. I want to put in the iron. There's nickel coming in on this one too, which is used in another freaking process. Damn. Chlorine. Okay, I like that one there. But this one here, if I change this, let's see, I got iron. Iron is coming out. Oh, something's... Yeah, I took into account the oxygen. Split Mars 3 separates as well as does whatever else it's supposed to freaking do. So let me take this out here. And what we're going to do is... it's iron oxide, 20 is it 2. Now if I didn't have to collect the nickel, I could grab sodium oxide, calcium oxide, and iron oxide, 20 of 2. Oh, something's wrong with my numbers. Because I've got 5 of 1 up here, that means 10 of 2. Iron oxide's 20%. Oh, so this should be a 4 down here. I don't know if those numbers are right up there either. Iron sulfide. I know what that is. I know what that is. Iron oxide. This should be a 4. This should be a 4 here. Silicon dioxide. Iron oxide. I don't need the potassium. I don't need that potassium. Well, it's a potassium is 21. It's 21, which is correct. See, the trace elements are more like down at the bottom, and I have to have 20 input to get that lowest output. So this is supposed to be a 4. For the iron oxide, it's 24. Why do I have... That's not supposed... That's supposed to be a 2 there for... Oh God, these numbers. Iron oxide 24, 10, 2. That means 2 oxygen, 4 silicon dioxide. Fuck. See, I'm trying to add up the oxygens here. Silicon dioxide is at 40%. Which is correct. So that's 2 oxides. That's 8. 8. And 2 is 10. 11. I'm counting 11 oxygen, not 12. So there's 8, 9, 10, 11. And that split. And then that's okay there. Alright, so now the question is... I got iron oxide coming out of there, and I've got iron oxide and silicon dioxide coming out of here, and aluminum oxide. That's actually 4. Those numbers should be okay. I know I gotta change that other stuff up there. I got 3 outputs there. Okay, that's 1. Now number split Mars soil 2. There shouldn't be iron oxide in the soil. Iron oxide's not in the soil. It's only in the rocks. And I'm only able to collect it with this split Mars rock 1. The aluminum oxide is supposed to be in the soil. Alright. Damn. Fuck. 80%. See, it's not supposed to be there. It's got to be in the soil. It's 10-8. There's aluminum oxide down here, and it's not supposed to be there. Split Marsol 1. Silicon dioxide, iron oxide. Silicon dioxide is in both the soil and... Maybe I change these numbers to drop down that amount. So what I'm going to do is I'm going to change... This is going to be aluminum oxide. Now this is going to be an 8, and what I'm going to do, I think, with the iron is drop it down to 10% of its output, or actually yeah, it'll just be a lot less. There'll be some there, but it'll be a lot less. It's more for collecting the aluminum oxide. But there's always going to be iron oxide in both areas. It's just not as prevalent. So 20, 40, 68. So 6, I'm only going to get... Yeah, that's about right. Now, for this here, split Mars soil 3, there should be... That isn't right. It's actually giving me more iron. Iron and silicon. So that's my silicon. But I've got silicon dioxide here, which is really the same thing. I don't even need, in fact, potassium. I don't even need this drill right here. I don't need soil 3. I think I can take it right out. Fuck. I'm going to take this right out altogether. I don't need it. Soil. This is the one that's got to have the aluminum oxide. And that's going to be an 8. And there's no iron in there. And now I can collect my nickel. Alright, so now on this one here, this is going to be, I'm collecting chlorine. I'm collecting all my trace amounts. Chlorine, potassium, and that one, that's Mars soil. Right, this is going to be a 3 again, isn't it? This would be a 4. And the numbers are all screwed up here. Changing all of that. Now I don't need... I'm collecting chlorine. Where's the nickel? If I took the nickel out here, sodium oxide, calcium oxide, and aluminum oxide. I'm taking the nickel out on this one. And I'm going to put it in on this one. That way, I can collect aluminum oxide. Iron oxide. Well, I've got 2 aluminum oxides. I've got sodium and calcium. Sodium is on 1, which I don't need. Or I could collect it again. I can collect it again with the calcium oxide and aluminum oxide. And that iron oxide's got to go. Well, no it doesn't actually. But I got 2 aluminum oxides, so that's defeating the purpose. Silicon dioxide. The silicon dioxide should be... Oh, that's in the rocks. Aluminum oxide. The aluminum oxide is not supposed to be there. Or it's going to be a small amount. So we're going to change it back to 1. And then put the correct, because that's just for iron oxide. What the hell? No, that's okay. Iron is a 1, 5, 1, 10, 2. The iron, the numbers are skewed. Wait, this is supposed to be a 10 here. This is supposed to be a 10. 20%. God, I gotta go through these fucking numbers again. Jesus. Silicon is at 40%. The silicon dioxide is prevalent in the same percentage in both the rocks and the soil? I don't think so. So I'm going to change this to a 1. If this is a 10... Fuck, you know what? I'm changing this to a 10. Jesus, all my numbers are going to be off again. Silicon dioxide is at 40%, but here it's at 20%. I don't want silicon dioxide to be that much in the rock. The iron oxide is in the rock, and that's at 20%. So that has to be a 2. Okay, now we're getting somewhere. Now here we're in the rock again, I got 2 silicon and I'm only supposed to get 1 silicon. I don't even know why I have this here. Aluminum, again, it's a 1. The iron is a 2. Magnesium oxide is at like 50% maybe. I get it at 30%. That should be more like 50%. Well, we'll make it a 4, I guess. Wait. No, that's 60. That's almost 70%. So this should be a 6 here. So maybe it's more prevalent in the rocks. Alright, so now silicon dioxide, that's 2 oxygen. 1 aluminum. It's actually 2 aluminum. Oh shit, that means this has to be a 2, doesn't it? Or is that, no, that's aluminum oxide, so this is 2 aluminum. So that means there's 3 oxygen, 5 oxygen, 6, 7 oxygen. Alright, that number is correct. I hate splitting this stuff here. Now split Mars rock 3, aluminum oxide is not going to be that prevalent again. I should have iron oxide here in this rock. Aluminum oxide is at 80%, so maybe a 2. Calcium, pyrite, magnesium sulfate. It's the only place I'm getting that out of. I might need split rock 4. Unless I got 20% iron oxide here. I don't need it there then. This turns into a 1. Okay, let's save this. Gotta get a lot of work going on. Alright, now we're down to here. Splitting pyrite, which is out of rock. All of that stuff can stay the same. Now the soil. That's all good. Iron oxide, yeah, 10, that's less. Aluminum oxide, that looks good. All of that looks good. I've got a lot of silicon dioxide in the soil. Yes, I agree with that. I got 10-1 here out of the rocks. And (10-4), which is the correct percentage, 40% coming out of the soil. I like it. And aluminum, so it's silicon dioxide, aluminum oxide, it's 40% for that. No, that's not correct. Aluminum oxide is 80%. That's 8 for 10. So this actually should be 16. It's 10-8 or 20-16, so that looks good. I like it. I like it. It's looking good. course, that drill's not using any sodium hydroxide, though. And it should be, because it's collecting all of that. No, it makes it, okay? It just makes it. What can I say? Damn thing's gotta make something, right? Alright, so now we've got chlorine and nickel. We got all that. That all looks good. Now the atmosphere, we've done all that. Oh my god, I think it's... Alright, so now I just gotta go in and check for typos. I'll just bring this over here, you can see that. Whew. Wow, what a job, huh? Okay, so Mars rock. Copy. Paste. Mars rock 2. Paste. Oops. Okay, this is all looking really good. Delete, delete, delete. I would probably have to look at the descriptions again, won't I? This is A3. Mars atmosphere. Paste. Takes care of that. Mars atmosphere 2. Paste. So what did I do there? I added the sodium hydroxide to all of that for lubrication. All of that looks good. All of that looks good. Now I gotta go and look at all of this. I don't even want to look at all these constituents. I mean, seriously, it's driving me up a wall. Silicon, aluminum. See, it's probably all frigged up. Silicon dioxide. It's not silicon oxide. Are we getting... We're not getting... See, that was a mistake that they made in the game. We're actually collecting silicon dioxide at 40%, not silicon oxide. So, shit. So that needs to be a DI. Silicon, aluminum, iron, yep. Silicon, aluminum, iron, magnesium, oxide, oxygen. Yep. Split pyrite. For sulfur. Now this one here, we get potassium oxide, and this other one, this is a lot to do. Sodium, silicon that's another silicon dioxide here. iron oxide and aluminum oxide, not aluminum. Sodium, calcium, and aluminum oxide. Chlorine, potassium, phosphorus pentoxide, and nickel. Carbon dioxide, argon, nitrogen, water. Split Mars atmosphere into methane. That takes care of all of the descriptions. Now the timing. Fuck. I don't remember if I changed that to 20. Now it's going to make a difference on my timing. I used this one here. I think that was a 20. So 20 and 0.2 is my magic number. I think. And I still don't know about this split pyrite. It's just frigged. 20 and 0.2, 20.2, 10.4. Okay, so 10 is 0.4. Is 0.4. Is 0.2. 10 is 0.4. 20 is 0.2. Yeah, it's all there. The only thing that's screwy is this here. Sodium hydroxide. I need. Now you know what I could do. Alright, let's try something here. Edit, copy, edit, paste. What I'm going to do is input silicon. Take that out, and then I'll put an output of oxygen. And then we'll get rid of all this shit here. I'll call this pi 2. You gotta have these different numbers. Alright, so oxygen. So this is just a test to find out how long it's going to take for this, because I don't know anything about these. So this should, all these numbers should be correct. Finally. Baby, that's a lot of work. Now this is why I run into that problem. I don't remember. Wasn't it 2 hours? I don't remember what the splitting number was. I supposed to do something? I've got to decompress salt to NMH. No. I don't have to do that. See, on the other one it's got 4 at 1 unit, and this one's got 0.5. It doesn't make any sense. This is what really drives me up a wall. I can't figure this out. Oh, I've got 10 units at 0.4. I think there's an owl out there. I feel like going out and talking to him. Oh, I put these numbers back before I went and tested him, didn't I? That's an owl out there. I want to go out and talk to him. So the only thing that I don't understand is that 4 at 1 on splitting this pyrite. I don't understand that number at all. So what I'm gonna do is restart the stream and we'll test this stuff. I gotta take a little break.